Welcome to the EclipseStore Fundamentals workshop. My name is Florian. I'm one of the co-founders of the companies behind the project, and I will give you an entry to how to use the library. And first of all, I will get into some theoretical part, what's the idea behind the project and why we did it, where are the origins. And then after that, we will dive straight into coding. If you want to, I provided a repository which you can check out and browse the code by yourself on your machine, or you can experiment by yourself, but it's not mandatory to follow the workshop because I will show everything I do on the screen as well. So, mandatory legal stuff. And first of all, what's the idea behind the EclipseStore library? Where was it born, and how did it get up with the ideas? We did a lot of projects back in the days, and we always struggled with getting the application fast, or to get a better experience as developers for developing, especially with databases. It was always a big struggle, and that's where the idea for the EclipseStore library was born. It's formerly known as MicroStream, but we moved the library to the Eclipse Foundation. Now we have the Eclipse serializer and EclipseStore to avoid confusion beforehand. And if you look at the state-of-the-art way how you can develop database applications, you're always dealing with foreign servers. So you do have, doesn't depend what database it is. It can be a NoSQL database, a classic relational one, or you can store your data into event streaming platforms, in-memory databases, and so on. They share the same drawback, because you always have to deal with two different data models. In your Java applications, you got your Java objects, your object graph, but the databases itself always have a different data model, like tables or key value stuff or JSON documents. There's always a mismatch between the two worlds. And therefore, you have to adapt your classes or your application with mostly a lot of effort, and you're strongly limited. You're ending up with a flat Java object model, and most of the time you need a highly complex mapping framework in between to get the data converted. And object relational mapping itself leads to tremendous loss of performance. And in most cases, an additional caching framework is needed as well to speed up things. And that leads to a highly complex architecture in your application. And on top of that, you have maybe a search server on the side, and you have to deal with special query languages of the database. And all of that is an infamous source of error. So you need experienced JPA or NoSQL specialists, and it's a highly effort and costly development process only to store data, basically. And it's for the maintenance, it's very effortful as well. So that's where the idea of EclipseStore was born, because we said that can be the state of the art. There has to be a better solution. So EclipseStore has a different approach. Because it is a newly unique storage technology which differs from the database servers which are on the market. we do store the Java object graphs natively, which means similar as are they kept in the RAM on the heap by the JVM, by the Java virtual machine, without any transformation to an incompatible data structure. So, and that's a key difference you have to keep in mind. What we do, EclipseStore runs inside your application. It's not a server. It's a library, which you can just add to your application. So, and this feels like a native Java function for storing data. The missing puzzle piece. The JVM itself is a very, very powerful piece of tech where you can do basically everything. A huge ecosystem Java provides. You can solve any problem except storing data. You always have to use a database. And that's where EclipseStore comes in and fills in the missing puzzle piece and provides kind of like a native store function for the JVM. So, and the upside is, of course, you only have to create one data model, your Java object graph, and no foreign format anymore. There's no more impedance mismatch, no more mapping, and no more loss of performance through mapping, of course. And that's what makes an in-memory computing paradigm possible in Java, basically. And you can max out the ultra-fast computing power of the JVM with the G compiler and all bells and whistles. And in the end, it leads to a more simple architecture because you only have your Java side without any caching frameworks in between, no relational mapping, no external servers of some sort. And it simplifies and accelerates your entire database development process. So, but this idea, this approach to persistence leads to a paradigm change. And that we have to keep in mind all the time. Let's see. If you have a classic architecture, let's say you have a relational database on the right side, or some data storage, it's always the source of truth. Meaning the application, which can be on a monolith or microservices or whatever, it just pictures the application side of an application design or of an infrastructure. You're always working with isolated user sessions, and these user sessions query the database and get back a copy of a part of the data. These are isolated, may not be in sync, maybe they're coming out from a cache. You never really know. And the object mapping has to be done for every single transaction. If it comes from the cache or from the database itself, it doesn't matter. And that's where the loss of performance comes from mostly. The network, of course, and the relational mapping. This is one of the biggest performance impacts. And so you have as well different responsibilities and different layers. So you have maybe a user management on the database side, you have validation on the application side, you have constraints in the database, and so on. So it's a big mix-up of responsibilities and different application layers. And of course, the two different data models you have to take care of and keep in sync. So with EclipseStore, the source of truth moved to the application side. The application now is boss, meaning we are operating on one shared object graph. Every user session works on the same copy, which first of all is fast, it's easy, but the only thing we have to take care of is we have a synchronization and locking on the application side. So we have to take care of that. That's a downside. but the benefits are tremendous. So only one data model, like I said, no more relational mapping and foreign systems. So, and the binary target depicted here is can be basically anything which takes bytes. It can be your local hard disk. It can be a blob store in a cloud like AWS S3. Anything which takes bytes. EclipseStore can write the persistent state to and restore the object graph fully or partially, depending on the lazy loading in the framework. That's basically the key difference between a common database application and an application where EclipseStore is used as persistence. So, first of all, if you have any questions, I will keep track of the chat, or you can unmute and throw your questions right in, and we can make it a bit more interactive. But in the end, we will have plenty of time for Q&A. Yeah. One question which fits right in. Does this also support loading and unloading parts dynamically? Yeah, that's what we do basically to ensure that the application can deal with bigger amounts of data as well. So let's say you have well, maybe 100 gigabytes of data, but your machine or your nodes only have, let's say, 4 gigabyte or 8 gigabyte of RAM. It wouldn't fit, of course, that you load all the data at once. That's why we provide lazy loading, and it can be done really easily, and you will see later on in the code. So, what topics we will cover today? Of course, a little overview in the code, just a little live coding, a simple example, how to get started, how to get your head wrapped around the API. And then I will share the repository. I just put it in a chat. So this is the repository I'm using, and we'll go through the topics branch by branch, and we'll cover the following points step by step. How you design a data model for an application, how to connect it to a storage. And then we'll see how to get data into the storage. Validation is always a topic. Then we will see how we can query data and store data, of course. And we can add any library you want, because we are talking pure Java here. So you can leverage the whole Java ecosystem and bring in any library you like, and EclipseStore will play along because it only keeps track of the persistent state. So we bring in, for example, Lucene for full text search, or different other libraries for validation, to see how you can interact with different other frameworks and libraries. Then the concurrency part we have to take care of. It's a big topic. And then after a short break, we'll go into some customizing stuff, like type mapping, what to do when your classes change, your code changes over time. We'll do some further customizing. We can explore what storage targets we are supporting, and backup and so on. There are a lot of features we can cover as well. And in the end, I will give a outlook of new features which are coming up. Yesterday we started our beta program for the Enterprise Edition, where the new GigaMap is part of. And in the end, I will show you what the GigaMap can do and the key features of it. Yeah, that's a good question. So Timo was asking when a bigger data set is loaded into memory, if it can be shown in a progress bar of some sort. We don't have a built-in loading progress listener, if you like, but the design of the API allows you to customize anything you need. So the engine itself is, or the API is interface-based design, so you can switch out any single part of the engine you have to customize, or you want to customize, and you can fit it to your needs. And of course, we are open source projects, so if you have any suggestions or ideas, you can participate anytime you like on our project website. Depends if this would cause significant overhead. If it's just a small listener which updates the user interface, I don't think it would be a big overhead at all. Yeah. Because it can be executed in a different thread, a UI thread, and the database uses own threads, or the engine itself has own thread management in the background. So it shouldn't interfere with the performance at all. All right, so the repository I put in a chat, you can see it as well. Again, if you want to check out the code, the code base runs with Java version 21, the last LTS release. But if you want to use an older version, you can reconfigure the Maven file down to Java 11. Java 11 is the minimum requirement EclipseStore has. And that's about it. Of course, Maven to check it or to build it, and the Git repository is here. So I'll give you a minute if you want to download the code and set up in your local environment. And then we'll head into the live code straight away. So let's see. If you want to use a different Java version, just open the Maven config and change this 3 values here down to Java 17 or 11, depending on what you want to do. Okay. So like I said, EclipseStore is just a library, so bring in your dependency. What you need to start is the storage embedded one. Currently is version 2. And the other dependencies we'll get to later in the code itself. So you start from scratch. Just let's create package and the demo class. The key type you will work with the most of the time is the embedded storage manager class, which can be created by some shortcut methods in the embedded storage factory type. And that's the quickest way to fire up a storage manager. And this storage manager is the connection between the object graph on a heap and the persistent state. So it will take care of restoring parts of the object graph in memory, and we have store methods to write down the changes to the storage. And that's the most important type you will see. And at the end, you can call it a shutdown, and that's the basic life cycle of the application. Most of the time, you don't have to worry about it because you will, for example, use frameworks like Spring or Micronaut under the hood, which take care of lifecycle stuff by injecting your storage manager. But by hand, the shutdown can be called in the end. What this does, it will fire up a storage, which is right now connected to nothing and writes on a local disk. But what we want to do is store data of some sort. So let's say we have a list of local dates, for example. This will be our data we want to store and restore. And therefore we can connect the, let's call it list, at startup. What this does, it tells the storage engine, hey, and this list is your root entry point in the persistent object graph, meaning every object which is reachable from this root on can be stored and restored by the storage engine. So think of a graph itself. You just define an entry point anywhere, and from there on, the storage manager can handle the state of this list. So when we iterate over the list and just print it out in a console, what will happen? Basically nothing, because there is nothing in the list itself. But if you look at our local file system, the engine created storage files because the default configuration is just a local disk with a directory called storage. That's where the default data will go, or the default binary target. And from there on, the data will be restored on every restart. All right. So let's add some data. We say now, and afterwards we have to tell the engine that the list has changed. So we just call store on the list. And at the next start, the list is still empty here, if you let it run. All right. But afterwards, we have added a date, so we should see it in the console, and here it is. So meaning the data we put in a list and we tell the engine to store will be restored automatically at the next startup. And we don't have to do any querying of some sort. The engine will just restore the mentioned root object on the heap, and the data will be available immediately after the storage is started up, and so on and so on. So after each restart, we add a new local date, store it, so it will be restored at the next startup. And that's how the engine works basically. You modify your object graph, tell the engine what has changed, call a simple store method, and the engine will take care of the rest. though that's the gist of the engine, and these are the methods you will use most of the time. You have a store, and of course for bulk storing, you have a store. So all method where you can hand over multiple objects to get a bulk store. If you have, let's say, if you want to do a transaction, and then everything will be stored with one I/O operation. And every time you can do that if you change more than just one single object. Best thing is to do a store with store all with multiple objects, because it results in one I/O operation. If you call the store with a lot of small objects, a lot of times, of course, every store object store operation will result in a different I/O operation, and that's the most expensive stuff you can do, I/O. All right. So that's the most simple hello world you can do with the engine. So let's take a look at the code of the demo itself. You can see this is this bookstore demo JSON, how's it called, is a smaller version of the big bookstore demo we have on our website. And I use it just to go through all the features step by step and don't have too much code to look at. But if you want to check out the big bookstore demo, which has all the stuff built in, you can check it out on our GitHub. Just go to the EclipseStore GitHub site and you'll find the bookstore demo, the big one, which can be run by one click on Gitpod. To check it out, it brings a user interface where you can see how it works with, in this case, Vaadin, which is a library which creates web interfaces. We added Lucene for full text search. We have GraphQL interfaces built in to see how it's done to access data from the outside, and a lot of other stuff. So I just clear the link and chat as well, if you want to look at it later on. So let's see. How do we design a data model when working with EclipseStore? We switch to the first branch. What we're dealing with here, the business case is like the demo describes here. It's a company that operates bookstores around the world, and we'll manage, of course, what books with all the authors, shoulders, and so on. We operate shops. We store our customers, of course, and their purchases. That's all what the demo is about. A retail chain with bookstores around the world. So when we look at the code here, it's just pure Java. Design your object model to solve your problem, to design, create your objects without thinking persistence in the first place. Because EclipseStore doesn't care how your object is laid out. And as you can see, we don't need any special super types or super interfaces or annotations or whatever, just pure Java. And therefore, you can design your object freely. And first, concentrate on how to solve your problem. And then we add EclipseStore afterwards and take care of the persistent state. And that's all about it. This data type here is our root object, where we connect the object graph with the storage engine later. So it's always a good thing to split up the data into different parts. Of course, you can put a lot of collections in the data root alone, but the code will be not very readable, so it's always good to split it up into different parts. Let's say, for example, our shops, which manages the shops. Internally, it uses an array list and exposes different stuff to the caller. So the caller doesn't have to worry about the internal data structures, but just calls your Java methods, which are you offering. And as you can see, you use collections like array lists, hash sets, maps, whatever you like. You can use all the data types Java offers you. You can bring in different libraries if you want to use different collection frameworks, for example, and most of the time you don't have to worry about how the data is stored, because EclipseStore provides data handlers or type handlers, as we call it, for the most common types in Java, all the collections, all the data types, and so on. And for every other type, we will create generic handlers, which just analyze the code you have, and then will break down the objects into bytes and write it to disk and restore it later on. But you can provide custom type handlers if you want to optimize stuff, or if the library is designed in a way EclipseStore cannot handle. You can always provide type handlers for that, and then you can persist basically every class there is in the Java universe. How to do special type handlers we will see later, or deeper customization. So if you look at a book, for example, just a simple POJO, you have the getters and setters in here. No special super typing or annotations you have to put in. And as we can see here, for example, we use instead of a double or a big decimal for prices, a specialized Java monetary API, which can be brought in as a third-party library, and EclipseStore will play along. So you don't have to do any special mapping to some database data type. That's never a case you have to do. Just think Java core, bring in your libraries, design your object model to your needs, and then you can go and add EclipseStore later on as persistent layer. So, so our customer here has a customer ID. This is not a technical ID like a primary key in a database or a foreign key. That's nothing you have to do. This is just a business value of the customer type, because we assign a unique ID to our customer for invoicing, for example, tax reasons. So we have a unique value in our customer, and therefore we can leverage it in the way we can access the data later on. So we don't put the customer in a plain list, but we put the customer in a map with the ID as the key. So we have a direct access to the customer later on, and that can come in handy because we don't have to scroll through the complete list just for a single customer, but we make a single lookup. We say customers get by the customer ID, and with a single lookup we can access our wanted customer. And this is a thing you have to think about. How can I reach my objects in a graph? In a database, of course, you have tables. You can fire up a select, where you say, hey, select all from customer where ID is 1, 2, 3. And there's no such thing here in Java, because querying your data is just Java core stuff. It has nothing to do with EclipseStore itself. You have to use the possibilities Java offers you, which is, for example, collections with fast lookup, which are maps or hash sets, or I can use Java streams to filter, to aggregate, and so on. So don't think by querying data to talking to a foreign system with SQL or a different query language, but just Java core. How would you access the objects with pure Java? And that's how you design your object model, or the way the data is kept internally in your managing types, because the caller of the customer class who says, hey, give me the customer by a certain ID or give me all the customers, doesn't care about what collection is used inside. And that's an implementation detail. So you can hide all the technical stuff from the caller later on. So one thing is, people ask a lot about, so what about if I want to access a customer not by ID, but by, let's say, his name and so on. And there we have several different ways how to get to the customer. And one way is to have different lookup collections in your code, or you can use Java streams to filter the collection, or we have a new feature, like I said in the beginning, which is called GigaMap, which takes care of indexing internally. But if you don't want to use the GigaMap itself, you want to stay in Java core, we can use different ways to organize our data. And this is done in the books type. So this books class manages books. That's all it does. So, but we want to have different lookup paths to our books. Let's say we want query books by the respective author. The author is stored in the book itself, so we can't go through the object graph because the author comes after the book, so we have to provide something in front of it. And a cool trick is to just have different lookup maps, which have a key for the value you want to ask and get the books for. And then you have a very short lookup path on the heap, and it's the fastest way to query data, because the hash maps are really quick looking up the stuff in memory. So don't worry about the memory itself, because no matter how many collections you're using, you don't put copies of the books in the same collections, but just different pointers. Meaning the book itself, one book itself lives only once on the heap, and you only have references to this book in different collections. So the memory overhead is very small for just a quicker lookup to different books. So that's one way to design a different lookup to or quicker ways to query your data. You don't have to do it, like I said. You can just use Java streams for that. For example, if you have the customers, the shops, a better example, you can say that we want to query a shop by its name, and we could provide a method which is called by name, and therefore we can use Java streams. So filter. First, well, it's null, or you can return an optional, depending on that. So just think Java core stuff, use Java streams to filter through collections, and you can create queries, if you will, so on your data, or ways to look up objects in your graph. This is one way to do it, or use different collections for shorter lookups. But I don't have to worry about too much about performance. Let's say you have maybe a few thousand shops on a planet. This is a amount of data you don't have to worry about. Just keep it in RAM all the time, and you can traverse the object graph without lazy loading. But if we are talking hundreds, thousands, millions, or billions of objects, then we have to think about lazy loading the stuff, and therefore using special connections for that, or you have to segregate the data in different parts, which is not always on the heap, but just for a certain amount of time when it's needed by the application. And that's what we did in the purchases. Purchases mean this can be a lot of data. If our shop operates for shop chain operates for 30 or 40 years, we have millions of, the business is well, maybe billions of purchases. So we have to segregate our data down, and the purchases, a good way to do it, of course, is by business year. So let's say we put the year as a key, and the yearly purchases here is just a bunch of collections where the purchases are kept, are lazy loaded. And this is the single only class you have to bring into your business code out from our library, which is a lazy reference. The lazy reference can be used to wrap around anywhere in the object graph. And from this point on, the data is not restored at startup, meaning the default way EclipseStore loads data is eagerly, meaning everything is loaded, put on your heap, the objects are created, and you can access it. But every time the engine sees a lazy reference in your graph, in your object model, it stops loading, and only if the getter of the lazy is called, the objects will be read from the binary store and restored on your heap, and you can access it from there on. It's just a simple getter, and the rest is done by the engine. The lazy reference, or the data which is behind the lazy reference, can be removed from the memory, of course, to avoid memory overflows or memory errors. You can do it by hand, just call clear of the lazy reference. But you don't have to worry about it because we have a lazy reference manager running in the background, which takes care of clearing all the lazy data from time to time, depending on what timestamp it, what point in time it was accessed the last. So it will see what data wasn't accessed for a while, and this one will be cleared out first. So the hot data stays in the RAM, and the cold data will be cleared out by the lazy reference manager. So this is the way to define lazy loading points in your application. And that's all you have to worry about in your object graph, or the only foreign thing you have to bring in. And the rest of the object model will be just your code, just pure POJOs. One question we get a lot is, why don't we use annotations? For example, we could have done that. Say, hey, load lazy from there. So this has two different reasons. One is if we use an annotation, the engine itself wouldn't have an entry point in a class model to interfere with data loading. Hibernate, for example, has the same problem. So what these libraries are doing, they do class manipulation at runtime and inject special code into your classes to manipulate the data flow in the application runtime. And that's one thing we didn't want to do, to manipulate classes at runtime, because it's a huge source of error and it's hard to debug, and it limits your object model again. And it's a bit of a smoke screen you don't really want to have in your application. And the second reason is you cannot put annotations everywhere. For example, you cannot annotate a generic type. That's not possible. So this solution here wouldn't be possible with annotations to lazy load up only the values of the map, not just the keys or the whole collection itself. This is only doable by concrete types. And this, therefore, these are the two reasons why we only have a concrete type and not an annotation. So we don't have to mess with your classes at runtime, and you're more flexible to define where to load the data lazily. So yeah, this is a quick overview of how you can design your classes. There are a lot of ways how you can do it. This is one way, but you're free to design the object model depending on your business problem. Yeah. So the next step will be how we how we connect all the data to a storage. And this one is in the next branch. We have a central type. We just call it books.demo. As you can see, it is a static type, or only the content of the class is only static. That's a quick and dirty way to solve it. You can, of course, use a singleton if you like. You can use, if you have a framework which you're building on, like Spring or Spring Boot, which uses dependency injection, you can provide components which are then injected by the engine. So there are a lot of different ways how to manage the lifecycle of a storage manager. But in this simple demo, I wanted to stay at core Java and make it as easy as possible. So I just created a static instances of all our stuff we need. We have our storage manager again, of course, which is created in this method. And there you'll see one way how to configure the storage in more detail. We have a builder pattern which just puts properties, and in the end you create a storage foundation, and based on this foundation the storage manager is created. The foundation is a way to configure your storage by code. So there you can exchange all parts of the engine down to the little detail, to the last bit of the engine managers, and bring in new implementations for different stuff. This is what the foundation classes do, and built on top of the foundation with a simple, just with simple setters or the storage configuration types. And if you want to externalize your configuration, like XML files, or you want to use the configuration of the framework, the application XML from Spring Boot or application YAML, and you want to put the properties there, we provide property readers which integrate nicely into these frameworks as well. or you can just read an XML file from somewhere and configure the foundation with external sources. Of course, most of the time you'll have a configuration for testing and configuration for development and one from production. So best is to have it in an external file, but you can do it as well. So here we see we define a different storage directory. Default case is local file system, of course. So we'll work in this data directory here. We set the channel count to 2, and then we are registering specialized type handlers for JDK collections. It's not a must, but we deliver tailor-made type handlers for collection types in the JDK. You can use them if you want better performance, but it's not a must. We provide different type handlers for JDK 17 types as well. And if new JDK versions offer new types, which we have to take care of, we always provide type handlers before the JDK will be released. So we are always ensuring the compatibility to the current Java versions while the Java version is still in beta. So when the Java version is released, you can be sure that EclipseStore works well with the most recent version, of course. All right, so, and what the heck is a channel? So if you start up this bookstore.demo again, let's just make this into a demo class again. So we just call it a shutdown method, and all the other stuff will be initialized statically. So what will happen if you look at our data directory, we will see 2 different channel directories. A channel itself is a separation of data. In the application, we have different threads which take care of I/O operations, and on the binary layer, in this case on our local file system, we have different channels, channel directories where the data is split into multiple parts. What this does basically is speed up your application, because the most expensive stuff you can do in any programming language or in any application is I/O stuff. And if you can parallelize it and use different threads which handle I/O stuff in parallel, you can speed up the performance of the engine tremendously. And I always advise customers to leverage the amount of cores they have at their disposal in the on their nodes. So let's say if you have an 8-core engine, you can use 4 channels for EclipseStore, and EclipseStore uses 4 cores in parallel to do the I/O stuff, and the remaining 4 could be used for the application itself. So I wouldn't use all cores just for EclipseStore, of course. We have to leave some for the application, but you should use about half of the nodes or the processes cores you have at your disposal. And that's what channel counts do. On the local hard disk, it's a slight performance boost. But if you're talking S3, for example, if you work in a cloud and you put your data into an S3 bucket, the channel, each channel will have its own connection to the S3 bucket, and so you can speed up the application much more if you have network stuff in between. So it makes sense to use more than one channel all the time. And this is just internal concurrency stuff for the engine. You don't have to worry about to split and join your data again. It's only used internally. The multi-threading synchronization is done by the engine. It's purely for I/O optimization. Yeah, good question. The channel count can be changed afterwards, but you have to keep in mind that the storage have to be rewritten once, because the objects you're storing in your application have to be spread over the different channels, and this is done with a simple hash modulo algorithm. And if you change the channel count, the algorithm has different results. So you have to rewrite the storage once, and let's say you're up from 2 to 4 channels. Then the migration tool will split up the 2 channels into 4 channels, and then you can restart your application with a different configuration. But it can be done. Yeah. This is one thing which cannot be done at runtime if you change the channel count. Most of the other stuff, if you, let's say, change your code, you add fields to your types or rename fields, this can be handled at runtime, the type mapping of the engine. But this stuff which regards the storage structure itself, which the channel count is, then you have to use the tool. Yeah, Sonic put it in the chat already. So you have to rewrite the storage once, and then you're good to go again. Yeah. So the channels itself. To explain the structure of the storage. What is written in the storage anyway? We have, first of all, the persistence type dictionary. This file keeps all the metadata of the structure of the classes we are persisting. There, the engine keeps track on what type is stored in what way, which types are used, how the binary data will be structured, and the binary data itself lives in the data files. And the data files are only raw data, only the state of the objects. The structure of the objects is handled in a type dictionary. And in these files, there is a transaction log, which enables us to restore corrupted storages, or it's basically a transaction log for the binary layer, which the engine uses internally. And these are all the different file types in the storage, description of the structure, the raw binary data, and a transaction log, and that's it basically. Yeah. That's the stuff EclipseStore creates in the binary storage. And based on this, EclipseStore is always able to restore your objects on the heap on the JVM. And that's all EclipseStore basically does. Keeps track, takes care about the persistent state of the objects. The next step is to bring in some data into our application. So just let me close the old stuff. We'll switch to the data creation branch. And here you'll see a random data generator class. We don't get into the detail here. The only thing it does, it generates some random data we can play around with in our application. Therefore, let's clear the data. And it just populates the shops, books, and so on with random data. Depending on the use case, you can adjust the amount of data which should be generated. We have in our bookstore.demo the random data generator with several data amounts. If you want to play around the small data, it's fine. But if you want to see how the engine performs with lots of data, you can of course use large or humongous. Then more data will be pumped in the initial storage, and it's done the way. If you look at this API, the root, there are actually two ways to connect the storage manager with the object graph. The first one is to hand it over at the start and say, tell the engine, hey, here's your root object, or you can use the API. It's to read. You can use the root method, and to set it, you can use setRoot. And these are the two ways to define the root object of your of the storage engine. And at startup, the demo just checks, hey, if there is no data at all, meaning the root is null, we will just create some data and let the random data generator do its thing, and then we have some stuff in the storage to play around with. On top of it, there is some utility stuff for monetary for the monetary API. Nothing we have to go into detail. It's just some util methods we use in the code base. The core stuff is still here, how the storage manager is fired up, and the lifecycle handling stays the same. Okay, how is the data brought into the objects? If you look at the books, we have some methods here which will write data, not only read, which brings data out, but we can bring data in with writing methods to add data to our collections. Let's take a more simple one, the shops, for example. The question, calling the data generation doesn't actually persist the data. No, it doesn't. If you change the object graph, you have to tell the engine what's changed, and the data generation, the data generator does it internally. It calls the store methods of the embedded storage manager in order to write it to the persistent layer, to the disk in our case. Yeah. That's because the engine has no technical way to detect changes in object graph. The Java virtual machine has no such ability to tell the application, hey, an object has changed. In order to track that, we would have to keep the data double in memory and always compare the data to track changes in order to store data automatically. But most of the time you want to control the transaction management by yourself. So only if some state is reached in your data model, the data which is brought in is validated and then properly put into your objects, then you want to control when the objects are stored, and that's what you do with the store method itself. All right. So we have two new methods to add, for example, a shop. And the one takes a shop, and the second one takes a persister as well. The persister is a super interface of different ways to store objects. The store method is defined in this interface, and you can just call it. The embedded storage manager itself is a persister, and this one you will use most of the time. But if you open, for example, a custom transaction, you create a storer, an empty storer object, store multiple objects over a longer range of time. This one implements the persistent interface as well, but most of the time you will just use the storage manager itself, and that's what the overloaded method here does. It calls the second add method and hands over the central static storage manager in our bookstore demo class. And the store method will be called on this storage manager. And all you have to do, if you manipulate data, in our case, we add a shop to our collection here, to our list. We have to tell the engine, hey, what's changed? Store this, single store call, and that's all you have to do to store data. There's one rule, of course, always store what's changed. The special case is with collections. Most people make the mistake when working with EclipseStore, and the first time they would call store on a shop because they say, hey, I added a shop, so I only have to store the shop. That won't have any effect because the referencing object has to be stored in order to store the reference as well. So in our case, it's the shops collections. And if you look at it this way, what we changed here is the shops collection, because we added a new shop. So we have to change to store the collection itself. Same thing is when you remove data. There is no way to delete data in an object graph. The way you remove objects from a graph is to clear all the references to it. And then on a JVM, the garbage collector will clean it out eventually, and that's the same in the storage. If you, for example, remove a shop from the collection, you store the collection as well because you changed the collection. And if there's no more reference to the shop will be cleared out by the garbage collector of the JVM. And the storage has a garbage collector as well, which takes care of the old binary data. So if objects cannot be referenced, they will be cleared out of the storage eventually over the time. Depending on how much time the garbage collector gets, it can be configured, or how write-heavy your application operates. It takes a different amount of time, but it will be cleared out eventually, so the storage doesn't grow indefinitely and has a defragmented state. And that's what the storage does in the background. Yeah, and if you want to add more shops at once, for example, you bring in a whole collection of shops. Therefore, we have the add all method of the collection. And so if you add more objects to the collection, just store the collection again, because we modified the collection. Store what you've changed. And that's just you have to know about how to modify object graph. Of course, you can modify how you like, how you design your application, but in the end, you have to tell the engine what's changed, call the store method on it, and then the persistent state will be written to the underlying binary storage. Yeah, another good questions. The store operation itself is blocking, meaning when the store returns successfully, the data will be written physically in a storage layer. That's on a built-in transaction. What happens behind a store call is following. We can open a custom transaction by ourselves. If you say create store, the store opens a transaction. You can store multiple objects in this transaction, and in the end, the store commit. This is how we can create a custom transaction, and this is done behind the scenes in the store call of the embedded storage manager. It will it will create a store, it will register the new changed objects, and when the commit is called internally at the end of the store method, only the changes will be written to the binary data, to the binary layer. And it's always only the changes are written. So if you have a huge collection which brings in 10 new objects, only the 10 new objects will be written again and the references in the collection. So you don't have to worry about restoring huge collections, only the delta will be written to the storage itself. Of course, you can use it in an asynchronous way when you use frameworks under the hood, which use asynchronous stuff. You can leverage the framework itself and call the store in a different thread. So you can achieve an asynchronous behavior, but the implementation of the store itself is blocking and asset transaction into the binary layer. So you can go sure after the store returns successfully, the data will be stored safely. Yeah, next point is if you bring in new data, of course, we have to validate it. In a database, you have ways to achieve it, or different frameworks you can use. In our case, of course, we only think JavaPro again. So the validation isn't part of EclipseStore itself, it's part of the application. So we can use default validation which the JDK offers us. For example, we can put it in a constructor. We can validate the fields and throw exceptions, or we can use Bean validation frameworks or Spring validation. There are a lot of possibilities you can use depending on what framework you're developing your application on. Most of the frameworks like Spring have on validation API, or just use JavaPro stuff again, and that's a beauty. When developing with EclipseStore, you can just stay in JavaPro and don't use any foreign stuff for that. And that's all about, you need to know about validation. Again, where you validate depends on your design, of course. One way is to do it in a constructor. You have data access objects which handle validation, or maybe at a REST layer, you can validate if you like, depending on your application design, but just think JavaPro again, and you're good to go. What's a good validation library we are using in a lot of projects is JavaBean validation itself, where you can you have a lot of predefined validators, for example, for emails or monetary validation or regular expressions and so on. And this is a library you can look at, or the validation of the Spring framework, or just Java core stuff, or custom validation, for example, an ISBN number for the books itself. It has a custom logic to validate an ISBN 13. You can implement it once and use it in your code. Yeah, a lot of ways to do it. But you have to take care of validation, of course, that you don't bring in corrupted or invalid data. So we created our data model. We brought in some random data, and I showed you how several ways to query your data. And for this, we have built in some more complex query stuff into the demo. This you can find in the queries branch here. We want to extract more complex data from the application. For example, if you look at the purchases, we have several query stuff down here. One of them is a bestseller list. We want to see what books sold best in a certain year. And if you look at the code, of course, you can design it again in a functional style, as we did here. We have stop method here, which computes stuff by year, which brings in a function which operates on a stream. So this is all, again, just Java core stuff. You can use for loops with ifs, if you like, or use Java streams or a different collection library of your, if you prefer, and use the Java API which they provide. And so you can extract the data from your object model. And if lazy loading has to be done in between, the lazy getter will be called. Load the data. The data will be loaded optionally if it's not on a heap. It will be merged into the live graph, and you can then operate on this object, and the result will be returned. So let's look at a simple example here. In our bookstore demo, we can access our data root. We have our purchases, and let's say we want the bestseller list from this year. And just print it to the console. We don't have data, so the first time will take a bit because the random data is generated. And afterwards, we will see the application run through. And the book sales are extracted from the database, from the object model. Because always say database because I'm used to it. The database in our case is the object model on a Java heap. So we will query data by the Java itself, and the optional lazy loading is done by the engine in the background without sending any SQLs or so on. That's a thing of the past. You only need Java core stuff for that. So you see, you have a huge amount of data which comes back. Maybe you want to page through the results, so you can use streams again, because you can offset and limit a stream to page through results, for example. Yeah, again, a lot of ways to do it. And if you start the application again, now we have randomly generated data again. It will be read from the storage and will be there in basically 0 time. So you see the loading goes really quick, and depending on the amount of data, only parts of the object graph will be restored in memory. So the querying happens on the heap. And this is really quick because if the longer the application runs, the just-in-time compiler of the JVM kicks in and will optimize the querying methods for you in the background without doing anything additionally in your code. The JVM features can be leveraged to speed up your application, so you don't have to do anything. And the longer your application runs, the faster the queries will get without coding anything additionally. So I will skip the full text part. Maybe we get back to it later if someone's interested in how to bring in Lucene, for example. The more important part is concurrency. And this is in the next branch here. Yeah, I mentioned it in the beginning. What we are doing here, we don't have a subgraph copies which we'll get from the JPA application, where we don't have to worry about concurrency because the concurrency is handled in the database. But we have a shared object graph which we are operating on with different user sessions, threads, and so on. So we have to worry about concurrency in the application itself. And this is a thing you have to keep in mind. If you run the application single-threaded, of course, nothing to worry about. But most applications are multi-threaded, of course. So we have to ensure that we don't get any inconsistencies. So there are a lot of ways, again, to handle concurrency. The Java itself has built-in stuff like the synchronized keyword, or if you synchronize on the object itself. For example, if you look at, let's say, book, we want to synchronize the access to our title field here. Just put the synchronized keyword in here, and then the threads will block each other. It's, of course, the easiest way to get application thread safe, but what this does, it makes your application basically or effectively single-threaded again, because all the threads will block each other, and that's nothing we want. We want multi-threading, fast-performing applications. So we have to work with read and write logs, which differentiate between reading and writing, which the low-level synchronization doesn't. It blocks everything. Therefore, the JVM has an API, which, for example, is called reintent logs. So the reintent log differentiates between read and write logs. It's a bit cumbersome to use if you worry about a log acquisition and log release in everything in method. Therefore, we have a little utility class in our demo here, which holds on reintent write log internally and offers read and write methods. The read method acquires a log, executes the operation, and makes sure the log is released afterwards in a final block. And this stuff you can call from your objects. Let's say in our books, for example, we have the write method, which adds objects, we wrap all the writing stuff in this simple write call, and the logging is done internally by the utility class. And the same with reading stuff. If you look down, for example, the all method, which returns all books, just wrap the code around the read, or wrap the read around your code, and the reentrant logs will use read logs internally, meaning all the read operations will be executed in parallel and leverage the cores you have on your machine. And only if a write log is acquired, the read logs will be blocked and have to wait until the write is over, so you don't get any inconsistencies. This code is the price for all the other benefits you get, or all the other features you get, but you have to do it by yourself. Where it can be done more easily is if you work, for example, with Spring Boot. In our Spring Boot integration, we have a different way to handle logs. We can look it up in the documentation. Old one, this one. We go to the Spring Boot integration. We have the dependency you can bring in, which integrates into Spring Boot 3. And you have a lot of features of Spring, which are leveraged, like the configuration layer or the component creation is all done by dependency injection. And we have an aspect for mutex logging. And mutex logging is done with the aspect-oriented approach, and can be done with another dependency where the aspect-oriented stuff is brought in. And then we offer a simple read and write annotation. And what this does is because Spring does class manipulation at runtime, we can bring in the logging code at runtime, and the logging code will be executed before the method itself is executed. So this is the easiest or most simple way to log your code to ensure to concurrency handling, just by annotating your methods with read and write. And that's all you have to do in the Spring integration itself. What this does, of course, it has a global write log. For example, you have logs like here. This is a global log. So if you write books and a different thread wants to write, let's say, on your customer, which wouldn't interfere logically, the write operations have to wait anyway, because it's a global log, and therefore you can use a log which differentiates. And in a Spring Boot integration, you can use a different mutex, which is used as a log mutex, and you can split up the logs into different sections. So you can have more parallel operations, even writing, if the code doesn't interfere. And if you, for example, have it in our purchases, when we say we add a purchase, this is all the writing code, but the log itself has a separate argument, the year, because we only want to log the business year, because we only manipulate this single business year, and all the other data shouldn't be affected by the log and can be handled in parallel. And what this does inside, we use a striped log. This is one way to create a more finely grained log. Either way, use striped logs in your application if you do the logging by yourself, or if you leverage the libraries we bring, you can define a different mutex and define more finely grained logs, which won't block different parts of your application. All right. So it's nothing most application developers have to do while developing an application, because you only have immutable data or copies of your data, so you can't create any inconsistencies. But the logging has to be managed anyway. In some point, most of the time, you have to leverage database features of your database server when logging. In our case, the source of truth is the application itself, so we have to do the concurrency handling in the application. And that's one of the small drawbacks you have to take or have to worry about. But regarding the many benefits you get, it's a small price to pay. In my point of view. So we are in the documentation anyway, so let's see. I talked about different storage targets. In our demo, we're operating on the local file system, like you can see. All the storage data is kept here and on a hard disk. But if you want to deploy our application to the cloud, for example, and we want to use S3 to write our binaries, because we can do replication of the data, or we have a more secure way of storing data, we can leverage, of course, the features in our cloud. So therefore, we are providing different storage targets. The default configuration of the storage engine uses the hard disk, and if you want to use a different one, we have to tell the engine what to do. In our example with S3, we have to bring in the dependencies for this. First one is our S3 adapter. And the second one is the S3 library of Amazon itself. All right, yeah. The AFS is one thing you will see in the code as well. AFS stands for Abstract File System, because the storage engine itself doesn't care in what binary target it writes. It only writes its data against the abstract file system itself. And depending what file system adapter is brought in, the actual binary data then will be written to the defined target. By default, it's the NIO layer, the Java NIO, which writes to path on the local file system, and different abstract file system implementations like the S3 one write to different binary targets. And that's how we have the abstraction brought in. So the S3 code, of course, you have to create your client and provide your credentials in which region you're operating in. And based on that, you can create a file system. This code is from the AWS library, and this code is from our library. We define a file system connected with the S3 client. And from this file system, we can create a path. which looks like, for example, the bucket name, my storage, or so on. And this can be given to the embedded storage manager. So that's one way to configure it by code. And of course, if you want to use external configuration, you can provide the properties in maybe a Spring Boot configuration, an external configuration, and then the engine itself will create the according file system and tell the storage manager to use this folder. So the file system implementation itself bring the adapters for this. So if you bring if you configure the storage in external configuration files, this code will be executed automatically by the engine. These are the two ways to bring in the configuration. Yeah. And here you can see all the different file systems we support by default. Of course, it's on an abstract layer. We had different implementations from users, which brought in, for example, in-memory file systems for testing purposes, and so on. So if you have a file system or a binary target we don't support yet, it can be adapted by implementing the byte handling in a custom-made file system as well. So this is the most basic stuff, like the CRUD stuff. How to create, read, and update data. And the next stuff would be schema changes. What to do when classes change, how to handle. This case is because the engine has a solution for that as well, of course. Like developers said, there's always a version 2. So you can take care of the changes of your classes to keep the storage compatible to the new added or changed fields. Yeah, so any question if the S3 connection can be used by S3 compatible blobsters? Yeah, it can be done. Most of the time, depending on the underlying blob store, like I don't know, the straight one or different cloud providers have different compatibility stages. I say most of the time the adapter works out of a box. Sometimes we have to provide some special properties in the S3 client to get the client working with the underlying blob store, but this is mostly documented by the provider. And from then on, you can use our default code as well. We had different cloud providers using the S3 connector, which had problems, and they looked up the documentation, put some properties in a client, and then it was working out of the box. As long as the file system is S3 compatible, it should work. Yeah. Right. So therefore, I have a few slides. What to do when our classes change. Long topic. So I'll see if the older slides. Yeah, we'll do it in the IDE. The thing is, we have to handle class changes eventually. If our application evolves over time, classes will change. The engine can handle these cases. And basically can handle all the cases there are. So if you rename an entity from a person to people or whatever, you can register the new class name at the engine. Or if you move the class to a different package, this can be done by a simple mapping table. But the most common case, of course, is if you add fields or rename fields or change a type of a field. The simple case handles just an addition of a field. These common cases can be detected by the engine. If fields are added, the algorithm checks the changes and we'll see, oh, there's only one added field. Of course, I can handle that by being sure what's changed. If the change can't be detected by the engine, or it's ubiquitous, the engine can't say, I'm sure what's changed, then you have to provide a mapping for that. And that can easily be done by either code or by providing a mapping file. And this one is described in our documentation as well, of course. We call it legacy type mapping. We have different cases, of course. A field has moved, has been renamed, or has been removed. The console will say, I detected these changes, I did this and that. But you can say simple changes can be handled by the engine, but what I will do is to always provide a type mapping just to go sure you keep track of the changes and the engine cannot make any mistakes. So you provide a simple mapping by a mapping file. It's just a simple text file where you describe the changes. On the left side, you have the old state. On the right side, you have the new state. This example says, hey, I renamed my order type to order implementation. And this one says, I renamed my field count of the order type to article count of the order type. And there you can tell the engine, hey, that's what's changed. And even if you have multiple changes over the time, just update your mapping file and inject the mapping file to the engine. And that's how you can ensure that the engine takes track of the classes, of the changed classes, and can load all the data. Because if you redeploy an application and the data has the older state, let's say the data says, hey, I know a field named count, but the current class on your class path has a field article count, the engine has to map it. And that's the way to tell the engine what's done. You can do it with CSV files, plain text files, whatever, or by code. Just call some put methods where you put the mappings. What we do in our project, we always use files for that. It's a single place where you have the changes basically documented from version to version. And that's a good way to organize the legacy type mapping. Yeah, that's the structural changes. And the other case is if values types change. Let's say you change one field from int to long or different stuff. This is value conversion. The conversions which can be done without any data loss are handled again automatically. If you change a field from int to long, the long is bigger, so the data can be converted. The engine does it by itself. But if you have more complex changes, let's say from string name to 2 string fields, first and last name, you have to provide a simple value mapper and register the value mapper at the storage manager foundation. And so you can handle value changes as well, or data transformations over the time. And that's the way you handle these two cases, the structural changes and the changes of types itself. Yeah, there's one special case described here. The deleted class. If you want to delete a class, the thing is, it can be the case that the binary data is still kept in the storage because the garbage collector wasn't ready or hadn't have the time to delete this data. So there's always the possibility that the binary representation of a deleted class is still be loaded at startup. Therefore, the way to handle class deletions is described in detail here. The best way is to just duplicate the class and keep it in the code base, or you have to you can call the full garbage collection on the storage once, and the garbage collector will clean up the storage. It can be a long-running operation, of course, because if your storage has several 100 gigabytes, it takes a while. But then afterwards, you can safely delete the class when you can go through that no binary data is left, which references this deleted class. Yeah. This is one special case you have to keep in mind. So one question, what about multiple iterations of change? Yeah, just add the multiple iterations of change to your mapping file, like here. Just write it down in a file from version to version, and the refactoring is done the following. When the application starts up again after a redeploy, not the whole storage will be migrated from the old to the new version. It will be only done on demand if the actual objects are loaded into the memory. Then the engine will load the older binary data, do the conversion, and create the object on a heap. And depending on how many changes have been done to the class, maybe there is a conversion from version 1 to version 5, then 5 conversions will be done, and then the class will be created on a heap. So you can you can reload really old data from the storage without any data loss, because it doesn't matter how many conversions are done. These are just multiple steps which have to be done, but it's still doable. And performance-wise, it doesn't have basically any impact at all. It's maybe 1 or 2%, because it's only a binary mapping in memory, which is very quick. And since we don't rewrite the whole storage when you define the legacy type mapping, but only when the stuff is loaded, it doesn't have an impact or a measurable impact to the performance. A new version of the classes or the objects are only written if you store the objects again. Then, of course, the new version is used, and at the next load, no legacy type mapping has to be done. But only in the cases where old data is discovered, the legacy type mapping is done on the fly while loading. Yeah. All right, so that's the way how to use the legacy type mapping if your data changes. And that's basically all the basic topics I wanted to address for today. I would say we have more time for Q&A, and afterwards I will give a sneak preview for new features which are coming up, which make a lot of stuff easier. I showed you beforehand. For example, we had to, let me look at our books. We had the solution for different lookups with different collections. Looks a bit cumbersome, and of course it is, because you have to worry about to keep the collections up to date. You have to add all the new books to the right collections and so on. And it makes lookup faster, but it's a bit cumbersome to code. And therefore, we have introduced a new type of collection we call GigaMap, which has some unique features where you can shortcut all this stuff. So as you know, no new questions, so I can get to the beta program. We started the beta program of the Enterprise Edition a few days ago. Just share the link here. This GitHub repository is there with a bit of documentation and examples. You just have to create a free account at our website and just follow this link. And in the cloud platform, there's an introduction where you find the libraries. It's just a repository you have to add to your Maven configuration, because we cannot deploy to Maven Central for license reasons. And then you can bring in the dependency and play around with the new features of the GigaMap. So the GigaMap itself has some unique features I will want to show you. Yeah, the GigaMap itself is a new type of collection which is designed to cope with vast amounts of data. And it has some unique features to do exactly that. It stores the data internally in nested, lazy loaded segments, which are backed by indices. Meaning all the lazy loading stuff is done internally by the GigaMap itself. You don't have to use the lazy API anymore for this case. And the indices offer a way to query the data before the data is loaded. Right now, if you use default JDK collections and you want to query the data which is inside the collection, of course, you have to load the collection first onto the heap. Then you can query the collection with Java core stuff. This can be problematic if you have huge amounts of data. So I talk tens or hundreds of gigabytes up because you always have to load the whole collection into memory. Of course, we are talking in-memory computing here, but with a certain amount of data, it can become quite hard to manage. And that's why the GigaMap has indexing built in, meaning this index lives on the heap, or off heap to be exact, on the JVM. The queries are done on this index, and only the results will be lazily loaded into the GigaMap on the heap and then returned by the query methods. And this allows for efficient querying the data without the need to load it all into the memory in order to query it. And instead, only the segments which are required to return the resulting entities are loaded on demand. And with this approach, the GigaMap can handle really billions of entities with exceptional performance. It isn't limited to the size limit of Java core collections like a array list or a hash map or a hash set, because they're limited by the integer max value, which is 2 billion, around 2 billion. But the GigaMap can handle up to the power of 50 elements. So I think this should be sufficient for most use cases. And the indices and the queries can be created by Java API, of course, because it's just another Java library. So again, no, it's unnecessary to learn another query language or indexing technique. Just use the provided Java API for that. Yeah. So what we bring by default is a bitmap index implementation. You can use default indexing. You can index any type of value, so not just primitives, like most databases have the ability to index like numeric values or strings or dates and so on, but any entity of your choosing. So if you have a shop with a certain address, for example, you can index by this address if you like, any Java object. And the bitmap index has as well unique indices and custom indices. We bring one of the next beta versions will have a Lucene index as well. Lucene is a Java library which can be used for full text indexing or even the newer version of Lucene of indexing for vector data. And it's a very powerful library, the de facto standard in the Java world. Every search or indexing product which is on the market has Lucene under the hood. And it's the most mature library in the Java world regarding indexing, and therefore we provide an adapter to Lucene. And then you can query the Lucene index, and the GigaMap will load the entities of the result lazily afterwards. So it's a quite powerful combination. And you can provide constraints as well to the GigaMap, unique and custom constraints to create some kind of restraints what you can put in a GigaMap or not. And that's why unique constraints can be useful, because if you have a lot of data in a GigaMap and only, of course, small parts are on a heap, because the rest is loaded lazily, you can't do unique checks by yourself by just iterating through the whole GigaMap and checking, hey, is a certain value present? We have to put it in the index. So just define a unique constraint, and the index of the GigaMap will do the unique check for you in the background. So how does it look? You can define indexes by code. It's just a simple class, and you have to implement the index entity. The index entity method basically just extract the value from the entity which should be kept in the index itself. That's all we have to do to define an index. And we bring predefined indexes for the most commonly used types, or strings, character types, numerics, booleans, the temporal types from the new or newer Java Time API, and for UUIDs. But if you need special indexes for several use cases, just return a different value. We can index every single type, so you're not limited to the predefined ones. You can index everything. So the queries itself are a Fluent Java API you can use. They are executed off heap, so it's a highly efficient, low-level memory modification stuff we use, and it's the fastest way to operate on a JVM. And since the index is kept off heap, it doesn't bother your garbage collector as well. So it won't have any impact of the JVM's performance as well. And if the index gets too huge, the operating system can swap it to the hard disk, because the off-heap region can be managed by the operating system. On heap not. All the Java objects itself live on heap, meaning the garbage collector takes care of this memory region of the JVM, and the operating system cannot swap anything. But the off-heap region of the JVM can be managed by the operating system. So we have basically infinite amount of data for the index, and it's the fastest way to operate on a JVM, and therefore the performance is really exceptional again. The results you get back can be streamed. With the Streams API, you can iterate or page through them, and the entities which are part of the result of the query then are lazy loaded on demand by the GigaMap internally. Nothing you have to do by hand. It's all done by the GigaMap itself. And of course, the GigaMap is fully integrated with EclipseStore. It brings own specialized type handlers for an efficient storing. It has a built-in detection of changed content. So if you, it doesn't matter if you update elements in a GigaMap or remove or add elements. If you call a GigaMap store afterwards, the GigaMap itself takes track of these changes and stores the referenced elements or the affected segments automatically. So just a simple store call on a GigaMap, no matter what changed in the map itself, you don't have to take track of this. The GigaMap does it internally, so just a simple store, and the changes are written to the binary layer. Yeah, it's an older slide. The beta is open right now, and the upcoming features which are coming. For example, we have more CRUD operations to do by query. We have more performance optimizations we can do, for example, partial index compression. And one thing is persistable lambdas for indexes. You will see in the code later. The JVM has one restriction. That's why we cannot persist lambdas, unfortunately. But we have a solution for that as well. So you can only have classes or anonymous classes in your code which can be persisted by the engine. Lambdas, unfortunately, not. Most of the time, it doesn't bother you, because in your business logic or in your persisted part are mostly just POJOs, and you don't persist logic. But the index itself of the GigaMap is part of the persistent layer. So the indexers are logic, of course, and have to be persisted. So it would be nice to that we can persist lambdas as well, so codes can be really short. But it's a a nice to have feature, but doesn't affect the gigamap feature at all. Another question I may have missed, but can I use Lombok annotations on the data classes? Yes, you can. To be honest, I'm not a big fan of Lombok, but it's more a personal choice. But since Lombok does pre-runtime compilation, it doesn't affect EclipseStore at all because it does the class analysis at runtime. Meaning you can use any code generator you like Lombok as well. Yeah. The only thing EclipseStore is interested in classes, like in the book type. If EclipseStore, if you say, hey, EclipseStore, store this book, what the library does is it's interested in the data itself, meaning the fields. Because the fields are the state of this object, all the methods are just logic and don't have to be persisted. So the code Lombok generates doesn't interfere with the logic itself or the state of the object. It's only syntax sugar at compile time. Yeah. So the gigamet itself can be used easily. I just do a short hello world. Therefore, we provided a version of this demos which use the gigamap in a separate branch. On the small demo here, it's a gigamap branch. If you go to the big bookstore demo on our GitHub repo, we have a gigamap branch as well, which uses the gigamap instead of the JDK collections. And so you can see how the code bases look different, or what the difference is in the code, how it can be used. And it's a small hello world. Let's say demo again. I create a simple person, which we will put into the gigamap. It has, let's say, a name, time, date of birth, create constructors on that. Etc. So a simple POJO again. And this POJO we want to store in a gigamap. So how is this done? We just have our gigamap.
Sorry, could I interrupt you? I think you're sharing the wrong screen.
Oh, I'm sorry.
Yeah, thanks.
Thank you. So here we are. All right. So what I did is I switched to the gigamap branch in our demo, and I showed the bookstore demo on our website. The big one has a gigamap branch as well, so you can check out the code base. I created a simple POJO called person. It has two fields, name and date of birth, and this one we will manage in a gigamap. Therefore, we create a gigamap type person. And we use a builder for that because we put different stuff in later on and say build. So right, so we can create a gigamap, and it's still it's quite basically the same usage as a default Java collection. You can add an element, add multiple elements, remove, update, and so on. Just quite a default JDK collection. But what's coming into play now, of course, are the indices. The indices can be defined in different ways. What I like to do is put the index in the project itself, or you can create a class person indices, for example. And we want to create 2 indices for each field, one index for name and one index for the date. And the predefined indexes we provide live in class the indexer itself. It's just the interface you have to implement. And the abstract implementations are subtypes of this. So you can use the abstract string. It's your name index. And the only method we have to implement is the index entity, and we extract the value which we want to put in the index itself. So in our case, the name. And the second index for the date. Therefore, we have an abstract local date index. Let's put type person again. Extract the value again. And that's all we have to do to define these indexes. Most indexes will just extract a simple value, but you can, of course, create range indexes as well. So if you say we have an index which defines the date range, we'll say, for example, so index by generation. We have was so millennials. Then we can say, hey, that's not a date index, it's just a simple byte index. We just give back a byte. Then we can say if so here, I don't know the exact range, I guess it's 1980 or so. Then we'll return the boomer. On the other hand, the millennials. So that's one way to define a range index. So you can say, hey, GigaMap, give me all the boomers, all the millennials, and you can put any custom logic in the indexes as well, and you can index not just primitive types, but complex types as well, which will be stored by EclipseStore accordingly. So for our case, just use 2 simple indexes, one for the name and one for the date of birth, and we just register this index in the GigaMap. We say with bitmap index, name index, and this and that's all you have to do. So this the GigaMap itself will take care of the state of the indices. So if you add an index after data is already in the GigaMap, it will re-index the stuff internally. And yeah, all the time you manipulate data, the index will refresh itself. So you don't have to worry about re-indexing and so on. It's done automatically. Only thing is, you have to keep in mind, you have to tell the GigaMap if you update an entity. If you say, if you add a person, the GigaMap has the logic built in, of course, because you call a method of the GigaMap. It will know, oh, I have something added. I will update my indices, or if you remove something, the gigamap will know. So you don't have to care about updating. But if you update a person, the gigamap won't know. If you say you have a person somewhere and you set a new name, the gigamap won't know because you only call the method of the person, so the gigamap isn't affected in any way. And therefore, we provided an update method where you say, hey, I want to update this person, and you have a consumer logic internally. So the update is done in the gigamap, and so the gigamap will re-index the necessary stuff. This is the only thing you have to keep in mind when working with this collection type. When updating the data, don't do it outside. Use the update method, and then the indices will be kept up to date. So next thing is we want to query data, of course, and therefore we have surprisingly a query method. The query conditions are built into the indexes, so we can use the person name index and say it contains ignore case John, and then we get all persons where John is in the name, and then we have different methods. We can extend the condition by joining with and or, of course, and we can execute the query, hand over consumer for the result, or we can just stream the result, or we can use the iterator, or we have collector methods where we can grab the result into a collection. For example, most of the time, I guess you will use to list. So you get the results in a list. And if you want a page, the result, you can use the overloaded constructors. Let's say we start at 100 and first. So we get the second 100 of the result. And that's all packed into a nice and concise Java API. And that's the way you can query the index, because this query here is executed on the JVM, side, on the index, and only the persons which are in the result then will be lazily loaded from the binary storage into your heap. So it's easy to manage a lot of data in one collection, because you don't have to load the whole collection onto the heap in order to query the data. Meaning loading storing to persisted store, not from in-memory cache. I'm not sure if I get the question right. But the gigamap itself, if the resulting entities are not on the heap, are not part of the live graph, it will ask EclipseStore to lazily load it. And depending on the binary state cache of EclipseStore, it will either access the binary cache, which is built in EclipseStore, or it will go to the binary target, to the hard disk or S3 or wherever you store your data. And depending on this constellation, the binaries are handled. Yeah. I hope I got your question right. So this is a small hello world, and if you see how the code base changes, let's take a look at the purchases, for example, or the books. The books had a lot of collections. Now we have one, the map, the gigamap with different indices, and the query methods are quite easy. If you search a book by title, for example, we just use the query method of the map. We have a read log again, and we return the resulting list to the caller. And so your code base gets quite concise, meaning you don't have to manage many collections for different lookups. So, but just one single gigamap for an entity type. You can define several indices depending on the lookup you need, and then just use the query API of the gigamap. And one other thing, which is a cool feature, if you look into our book, which has all the indexes, for example, the book has an author, of course. This author is only referenced by the book itself. We don't have a collection anywhere where all the authors are stored. It's not in a data model. It's by design, because we don't need it. The data itself has only the books. The books are kept in a collection, and the book itself will reference the author. So, but maybe we have somewhere a listing on our website which lists all the authors where we provide books for, or sell books for. How do we query all authors we have? One thing we can do, or we could do, is to query all books and group them by the author with a distinct stream, maybe, or put all authors in a set, and then we get all different authors we have. But this would be a quite expensive operation. We don't want to load all the books just to get all the different authors. And that's why we have a cool feature of the gigamap itself, because we can use the index, because the author itself is in the index. We have here the index for the author. So the authors are kept in the index. So we just can ask the index to return all the different authors we have in our gigamap. And that's done by the index itself. We just say, hey, author index, resolve all different keys which live inside the index, depending on this certain map, and then we get back all the different authors of our books. So it's another way where we save management code by ourselves. We don't have to manage all the sub-entities or all the stuff, all the predicates of our entities separately in different collections. We just can look up the index of the gigamap. So, I overlooked the benchmark questions. We don't have any benchmarks yet, but we will provide some in the future with all the standard query stuff like range queries, like queries, and so on. So there will be benchmarks soon. Yeah. I don't know the pricing model for it. but as far as I can tell, it will be priced per application and not per concurrent user. That's the information I have. I don't know. There are no prices fixed yet. But as soon as the pricing model is available, it will be can be looked up at the website, of course. Yeah, but it's not finalized yet. Yeah, but what I can say, the GigaMap queries will be way faster than the other way around. If you have the possibility to keep all your data in memory, the GigaMap isn't needed because you can query it on the heap with Java streams. It's on a heap already now, so you can use Java core stuff. If your data is big, and that's what the GigaMap is designed for, if you have a huge amounts of data and can't keep all the data on a heap all the time, but you have to lazily load parts of it, that's where the GigaMap has its advantages, because the GigaMap only loads the needed data onto the heap depending on the query. That's nothing you can do with JDK collections, because in order to query JDK collections, you have to load it completely, because there's no index built in or no way to query the collection beforehand. That's a big difference. So it's designed for big amounts of data, or in the case when the storage exceeds the amount of RAM you have to at your disposal. Any other time the data is on heap anyway, small collections, which I advise, the hot data you query all the time, just keep it on heap, and it's as fast as it gets. All the other stuff can be handled by the GigaMap. Yeah. All right. So yeah, feel free to give it a try. You can just feel free if you have any suggestions for EclipseStore itself, or for the GigaMap, or different other frameworks we provide. Feel free to open issues or discussions. Always welcome. And the enterprise stack, of course, is not open source, but if you want to participate at the bookstore, at the open source libraries, you're welcome. Only thing you have to do is to get you have to sign the committer agreement at the Eclipse Foundation, and but it doesn't. It's for free, so you don't have to pay for it, and then you are able to commit to the project if you like. All right, so that's all the stuff I wanted to go through for today. If there are still questions, yeah, feel free to post in a chat or unmute. Of course, if you have more questions, open discussions on the GitHub side, and my colleagues will answer it there if you have ideas later on. Yeah.
I do have a question. I'm gonna do it now. So
Yeah.
the camera around so that you're seeing a face at least once. Hello.
Hi.
You skipped the backup topic.
Yeah.
Kind of.
Backup. We have two different backups: one full backup and one incremental. Full backup is just a method call where you can say, hey, write a backup to this binary target. And the incremental backup will just incrementally, like the name says, write to a different storage target. So you can have your live storage on the local disk and a backup at S3, for example. It's just a configuration. And that's
Is there anything that needs to be considered when we restore a backup?
Come again?
Is there anything that needs to be considered when a backup gets restored?
Not in particular, no. It's just binaries. So if you tell the engine use the backup as live storage, it's the same. Yeah.
Okay. Yeah, that was my question.
Okay.
Thanks.
So if no more questions are coming, I thank you for joining. Yeah, I see. Can I give an example of using EclipseStore as cache as a simple application on store with cache and is live, for example, not 6 months or 200 GB space on disk? Yeah, that's a lot. I see. If you like to use EclipseStore as a simple cache, we do have a JSR 107 implementation known as JCache implementation, which are used, for example, by the JPA second level cache for Hibernate or different other frameworks. Show the screen. Here it is. So, like I said, we provide a JCache implementation. Use cases are second level caches or for Spring Cache abstraction, and EclipseStore can be used as a persistence for the cache itself. And the JCache API has the ability to define time to live, cache eviction strategies, and so on. And the implementation uses EclipseStore as a backing store for the cache, and that's what you get out of the box in the library. But I don't know of an example with your figures. I think you have to try it out. Yeah. Depends on the memory you got. Yeah. On the other hand, yeah, if the cache runs out of memory, the eviction strategies will take place. So yeah, that's what the cache itself is for. Yeah. So it should work with an arbitrary amount of storage. Yeah. Thank you as well.